A very good afternoon, everybody tuned into this webinar today. Welcome to the November edition of Responsible AI, a webinar series which is an in-depth series on responsible design, development, and the application and use of AI. And we do this to inform anyone with an interest in responsible AI about tools and methods and best practices or lessons learned by various speakers that we have invited into this webinar series. This specific edition is about how human-centered and responsible AI can actually save lives, as we're talking about the medical domain today. My name is Tim Pauw. I am the CTO of Xomnia, which is a data consultant in Amsterdam that organizes this webinar series. I have a background in data science. And the guest speakers today are from the healthcare domain at Philips, so the big medical company here from the Netherlands. And it's awesome to have them here today. And also, I think it's great to hear that companies like Philips, with such a huge impact in the medical market, pay so much attention to responsible AI and human-centered design. So I'm really looking forward to the talks that we have today. Some general notices before we actually begin. If you have any questions, please feel free to share them in the chat on LinkedIn or YouTube. We will then get them. But please do note that there is a slight delay in the actual broadcast. So it would be very convenient if you could share the questions already as soon as you have them during the talks, for example. And then after the talks, we can actually answer them. So I will go to my next slide, which is the program for today. So we have two speakers, the first one being Jon Pluyter. And we'll first have the first speaker, then we have some time for Q&A, a couple minutes. Then we'll have the second speaker, Arlette van Wissen, and we'll have some more Q&A at the end, maybe with the two people combined, Jon and Arlette. First, we want to go to the talk by Jon. I'll quickly introduce him. Jon is a senior usability engineer at Philips. And as he says himself, his main responsibility is improving the usability of medical technologies at Philips, and by doing so, improving the patient safety, like the final stakeholder, of course. He has a background in information management and a PhD in that was focused on the cognitive and physical, or the cognitive and emotional overload in surgeons during surgical procedures that were imposed by medical technology. So how do surgeons actually react emotionally, for example, to new medical technologies when they are doing surgical procedures? It's also a super interesting topic. I don't think he's going to talk about that today, because of course the main topic for today is how at Philips they use the human-centered design process to create these new AI applications in their healthcare domain. So with that, I'd like to give the word to Jon. And I want to thank you, of course, for joining, but take it away.
Yeah, thank you, Tim. You can hear me well and see the slides?
Yep.
Yeah, good. Yeah, thanks for the introduction. So I would like to start with explaining a bit about how we deal with AI in healthcare in Philips. So in general, there's quite a lot of attention about AI, and definitely also about the how to make it human-centered and bias-free. And yeah, we're going to show you a couple of case studies that I think will bring that to life, and also explain more about how we create it and potential tools that can be used for that. So as a starting point, we are thinking about human-centered AI and responsible AI in the context of radiology. So in general, if you look at healthcare, there are a lot of challenges and there's a lot of pressure on the healthcare system, and that creates issues for which AI might be part of the solution if it's done well. So you see here quite a few different things. So it's about clinical decision making and having AI in place to help physicians make the right decisions. But it's also, if you look at the bottom left, to reduce the burnout and workload that is currently put on a limited amount of healthcare professionals. So more care, older population, and but also a lot of more administrative tasks that they need to do. And we think that AI can also play a role in these kind of areas to free up time and basically spend more time with the patient and in the care process instead of on operational aspects. So that needs to come together. In this talk, we're going to zoom in more on the clinical decision support domain. And just to give you a feeling, these are some visuals of the context of use where AI can also play a role. So you see here on the right-hand side, radiology workstation where images are looked at, like CT and MRI images. And in the left-hand side, the spaces where these images are taken. And as you will see through the talk, AI has a big potential in this domain. Radiology is also traditionally one of the more kind of high-tech domains, which is also fast with innovation. So it's a nice domain to look at for this purpose. And I think one important thing to mention is that AI doesn't stand in itself. So as you can see it here, it's always a combination where clinical data comes together with AI that gives interpretations of this data, combined with the domain knowledge of the physician. So the purpose is not to replace physicians, but basically to help them work better, work faster, work more pleasantly, and thereby also impacting the patient and the efficiency of the process. So empowering the people and really kind of fitting their way of working. So what I would like to show you is a video that we created for a big radiology conference. This is work that was done by a couple of colleagues of mine, together with also many people from Philips Research. In design, it was Jaap Knoester and Sean van Orde Granger. And basically, they set out to depict what AI can do in the radiology domain. And it's nice to get some hands-on feel of what it can do. So I will play the video for you.
Meet Frank. He's been scheduled for a cardiac CTA because he's been experiencing strange chest pains. Our smart assistant helps him at every step of the way.
Hello, Frank. Are you ready for your imaging exam?
Planning an appointment that's convenient. Getting to know him better to ensure he is properly prepared. The assistant offers advice and reminders along the way. And if unavoidable delays occur, it can even adapt the scheduling to provide a frictionless, stress-free arrival for patients and staff. In the smart changing room, relevant measurements are captured, so the scanner is set appropriately. A virtual nurse makes sure Frank is fully prepared. Frank is gently guided throughout the procedure, while staff are assisted in setting up a personalized exam. A central remote expert and our adaptive intelligence will help drive consistent, high-quality imaging. Our AI workflow engine processes the data, extracting the initial findings, and checks for anything that might be missed before the case is referred, using an international network of radiologists. Traditional reporting and case files are represented by a digital twin of the patient. This living collaborative document is used by all specialists involved, facilitating integrated precision diagnosis. Aggregated data enables findings to be viewed in the wider patient context. Specialists can go deeper into the data using powerful simulations and comparisons with similar cases to make recommendations based on short and long-term forecasts, while reporting and scheduling of follow-ups becomes an automatic byproduct of the process. Meanwhile, Frank can track progress from home. Communication with the referring physician is supported via the digital twin, which also helps make things more understandable for Frank. These new imaging paradigms give radiologists the flexibility to work anywhere, while remotely providing urgent input when needed. and driving collaboration between disciplines to extend the value of radiology. This enhanced patient journey allows people like Frank to once again live life to the fullest. As we look to the future, we aim to build on our promise of partnering with you to seamlessly connect data across all moments of the workflow in order to drive continuous improvement in line with the quadruple aim and empower the people behind the images.
Yeah, so this I think shows quite nicely what AI can do, right? Because we talk about AI as a technological component, but here you can see what kind of transformation it can bring to healthcare. And at the same time, you see that when you now go to a hospital, this is not the reality yet, right? So what are the barriers that kind of are there that are blocking this from moving forward? And we think a big part of that is also the human-centered design of the AI itself. So let's go a bit deeper into that. So what you see here is taking a systems perspective, which I think is always really important when you innovate in the healthcare domain. So we really have to be very much aware of the context, not just of the technology itself, but the people in the process, the tasks and the work that they do, and our solutions really need to fit seamlessly into that high-paced, high-stake context. It needs to fit the hospital organizational context and the tools that they already work with. So this is quite a complex system, and that's I think why adoption is also challenging, not just for AI, but in general in healthcare. New technologies need to be very well designed to be fit for purpose. So what you can see here is that systems perspective applied to the example that I just showed about radiology. So you see the workflow going from scheduling to image acquisition, interpretation of the data, the reporting, and then the shared decision making and follow up. So it's kind of the flow that you also saw in the movie. And in all parts of the processes, data is being collected, and AI can help, as you saw the examples, in very small parts, and also in a way that is almost there in the background and providing the support without having additional burden. So then the next question is, how do you do that? And I want to share a methodology that we use that at least helps us a lot in building it in a human-centered way, which is the co-create methodology. And this is the way that we treat it as Philips, but there are also other related methodologies out there. And I think for me, the essence of this is, I will go a bit through the steps, but the essence is the co-creation. So not creating technologies for physicians, but with physicians, so that we can really get a proper understanding of this broader context that I just sketched. And the second part of the word is creation. So not just thinking on in our head, writing things on paper, but really kind of creating the solution in low fidelity to higher fidelity, so that you have something to bring to the physicians and put in their hands, so that they can try it, even without it being an end product, but trying like you have with houses as well, mock-ups, so that you can really understand better what the problem is and the solution. So this co-create methodology provides anchor points for that in 3 phases. So discover, frame, ideate, and build. And I will go through them in a bit more detail. So first, it's about really understanding the current context of use, and this is really important in healthcare, that we understand the types of systems that they use, and that we don't integrate or that we don't put AI as yet another application which is disconnected from their primary workstations, for example. So these are very important aspects of adoption. So this is typically what we do to start with, is really get a proper understanding, go into the hospital, understand their workflow, but also their kind of decision-making flow. So we want to understand, if you talk about AI and medical imaging, how do they read these images? What do they look for? If they look for example, lung cancer, what do they pay attention to? And then AI can help in parts of this process, but we really need to understand in great depth how they make these decisions if we want to time the AI in the right place. Then from there, it's about framing. So through that contextual understanding, we get a much better view on the problem. And I think that's a super important aspect of this cycle, is that you don't get stuck with the first request, right? So if you ask a doctor, they will say what they need, but it might be not what they need because they don't know what the possibilities are. So through this understanding, we can get a better understanding of what they need. And then an important aspect is that we start to create things very early on. So as you can see here, that's something we don't do in isolation. We typically work with co-creation workshops, which are very multidisciplinary. So we have designers, AI developers, clinicians or clinical scientists in our case as well, which are part of Philips. And through that we create things and we iterate. So with these created artifacts, then we can do testing and get feedback, and through that understand the problem better and also the solution to that problem and refine it in great detail. So then we validate. So what we typically do is we co-create with a few different hospitals, 1 or 2 or 3, depending on the project size. And then we also need to cross-validate it, because the complex system that I sketched is not the same for every hospital. So we really need to look carefully at cross-validating our insights in different places, and through that building an understanding of what is the common aspect in the problem and what is hospital specific, and that allows us also to focus on solutions that are scalable and reusable in different contexts of use. And then I wanted to spend a few words also on, because the last part, what I just explained is really also about understanding the problem very well and having a creative process to refine that. At the same time, you kind of, through these iterations, go more from making the right thing to making it in the right way. And for that, I wanted to point at some guidelines that are also publicly available, that help in shaping the collaboration between the physician and the AI, or in this case, more general about the human and the AI. So I think this might be a useful tool if you're looking into these kind of questions. And it explains general design principles about how to basically design that interaction between human and AI and how they collaborate over time. So just to have one example, that trust is a very important aspect in human AI collaboration. So if the AI would say, looks at the medical image and says, hey, I see a suspicious spot at the lungs, it might be cancer, will a physician then trust that or not? Because they have to make a very high stake decision using that information. So one of the principles is also to look at the need for example, explainability and understanding what else the algorithm needs to communicate in terms of, for example, how it reached that conclusion, what parts of the image did it find suspicious, and why was it a big spot or a small spot, and if we align that as much as possible with the way that these radiologists also look at the images, then the algorithm becomes less of a black box. So this is just one example of the way that you can also shape this collaboration between human and AI and make them understandable for each other. And that's the end of my part.
Thanks, Jon, for explaining this. It's a super interesting process that you guys are using. By the way, if anybody has a question, then please feel free to put it in the chat at at the medium that you're actually looking at, YouTube or LinkedIn, for example. In the meantime, let me ask a question. So I was wondering, is this like a recent thing for Philips to work like this, or has Philips always been using these kind of processes to create these medical technologies? Because because maybe back in the days it was just programmers. Okay, let's just start programming.
Yeah, exactly.
Or is
Yeah,
how
I think you see different directions, and that's also good, I think. So just human-centered is also not always the right thing. You always have this. You need this tension, right? So we look at it from the human-centered point of view, but you also need, I think, bottom-up technological push, and because yeah, there might be things that you will never think about when you follow the human-centered approach. So I think it's very complementary, and both approaches have been used throughout the company for many years. But I think AI also brings different dimensions and nuances in that model. So maybe one example is that if you want to quickly create prototypes, how do you simulate AI then in a relevant way? Because it's very useful to put AI in the hands of a physician very early, but you need then a realistic simulation of that AI so that they can really try it and therefore feed these insights back into the AI development process and the data collection process. So that is, I think, unique to data-driven or AI-driven applications.
All right, and is it so? Okay, so everybody is also on board with this with this methodology, or is it? Are people like, why do we need to actually?
Yeah, it depends. It depends. So some more than others, but yeah, I like the tension actually. It's nice to have different directions. People looking at it from a more technological point of view or a human-centered point of view, and
Yeah.
I think the most important thing is that you need to kind of respect each other's perspective and try to meet and be in these workshops, for example, where you can really find the middle ground. And I think that's where the real new things, the interesting things happen.
Cool. All right. Thanks. So we also have a couple of questions from the chat. I'm looking at my colleague here to highlight the first one. So here we have a question by Maarten Luiks, who has the question: is the digital patient, and I think he means also the digital twin thing, kind of an electronic patient file?
Yeah, exactly. So, but the electronic medical record, as it is currently in the hospital, is much more. It grew out of a more administrative tool, right? So, it was more purposed for reimbursement and insurance type of purposes, and then it grew over time into a patient record. But through that, it's also more difficult to really get an integrated perspective on the patient. And the digital patient is an attempt to integrate that information in a way that the physicians think about it. So, yeah, if you have a certain disease, why not cluster all the information around that disease instead of breaking it in silos for radiology or pathology or what have you?
All right, cool. It's at least it also looked really a lot better than what I know medical electronic patient files look. But
Yeah, for sure. Yeah.
okay, so we also have a question from Siddharth Mirota, if I pronounce it correctly. So for human AI collaboration in radiology, how can we actually ensure that the trust in AI is appropriate? So not too much trust or not not enough trust.
Yeah, exactly. Yeah, I think it's the right nuance. So it's not about making people trust. It's about reaching appropriate levels of trust. So yeah, it's a challenging question. I think how to do that, but yeah, I think it's one route to take is focus on this human-centered aspect. So if the algorithm makes a decision, and for example, you can calculate also the let's say the self-aware confidence of the algorithm. So if it gives you a prediction and it would bring a nuance saying, hey, this looks like cancer, but I actually have not seen a similar case in the past before. That tells you something because it gives some sort of exotic prediction out of the comfort zone of the algorithm, to put it in a human perspective. So I think there are many ways to try to achieve this, but it's not easy. And I think maybe the other point to mention is that you need to measure it also. So that's something we're working on as well, is how do you measure trust, and can we test if our if the design interventions that we have really work. So that's important because it's a bit unpredictable sometimes how people respond to the designs.
Yeah, I can imagine. Okay. So we have another question from LinkedIn from Sameh Mabrouk, who asks, is human-centered AI also being used at Philips, like outside of the healthcare domain?
Yeah. So we do more and more healthcare, of course. So, but if you look at, for example, healthy living at home or hospital to home type of purposes, so then you're outside of the hospital environment, but you're still in healthcare or personal health. So yeah, there's a lot of work there as well. We just chose not to focus on the radiology example, but if you look at toothbrush or all sorts of personal health applications, there's also a lot of AI.
Okay. And you also work on that, or you are like specifically focused on?
Yeah, me personally, I'm focused on the healthcare medical professional audience. Yeah.
All right. Okay. Thanks. I think that was it for the questions. So I want to thank you for giving such clear answers to them. And I think if Fitz can pull my main slide back up, we will go on to the talk by your colleague, Arlette van Wissen, who is a senior scientist at Philips. And she focuses on human-centered AI, for example, leveraging AI for conversational intelligence and content personalization to increase the engagement that the patient has. She has a PhD in artificial intelligence, and from the looks of her LinkedIn, she's building quite the impressive career in the Netherlands and abroad, focusing on AI and clinical decision support and all sorts of AI applications in the medical domain. So I want to ask her to, or invite her up to the virtual stage for her talk about responsible decision making in the AI lifecycle. So Arlette, welcome. Thanks for joining us, and feel free to start your presentation.
Thanks, Tim. So can you indeed see and hear me?
Yep.
Yeah, perfect. All right. Thanks, everyone. I think this was a great talk by Jon, who kind of set the stage for why it is so important to really tackle AI solutions from a multidisciplinary perspective. I will also address this, but going more from the entry point of the technical point of view. And what I will be talking about is why artificial intelligence comes with real responsibility. So I think overall, there is no lack of AI enthusiasm currently, which is great. I mean, I'm definitely one of those people who is also an enthusiast. But then I think we also have seen a lot of examples where although AI can bring it has a lot of potential, and it can bring so much, to healthcare in terms of efficiency and accuracy when it comes to prediction or diagnosis or workflow efficiency. But there are also an increasing number of examples where actually AI is introducing new problems. So this means that we also really have to look at the more who is responsible for those problems, right? And at Philips, this is also something that we try to look at. So I wanted to start by zooming out a little bit to sketch those problems, and this is from a paper that's very interesting, and it highlights these different phases you could say that you encounter when you're designing AI algorithms. So first is the world. The world has its own problems, right? So in terms of there is not equal access to, for example, to healthcare and access to facilities. There are actually discriminatory processes in place, and there is bias in physicians. So this is happening in the world, and that then translates to the data that we are collecting, that we're using to build our algorithms on. So we can have different sorts of biases in our data set, and then also in the distributions of that. So when we're designing based on that data, we might get biased design, and that could be either because the ones setting the agenda or defining the objectives for the models have biases, or there are different kind of agendas at stake. Could be also because of the choices we're making in creating these algorithms or how we test them, and also the choices we make when it comes to monitoring them or how transparent they are. And then there is the use or the more interactive component where the data that is fed back to our algorithms could be biased, or it could be that our applications are not used in a way that they were intended to, which creates a shift. So there are just all these kind of different things at play that can actually impact, even though we have very good intentions and we try to make the best products AI-wise that we can, that we are creating new problems. And in healthcare, I want to kind of give you examples for these different elements, why in healthcare this could even be a matter of life and death sometimes. So here you see a very interesting activity that a student has taken up. He was studying, and he found actually that what he was being taught as a doctor did not represent Black people for most of the time. So certain clinical signs actually do not present the same on dark skin as they do on white skin. So sometimes he had his educational book, and the examples that were shown, or the type of phrasing that was used, was really biased towards white people. So he created this book that said, okay, listen, often when it comes to symptoms or descriptions, you're thinking of this, but this really manifests in a different way for Black people, and we should account for that. So for example, also in terms of COVID, asking patients or their family members if people are pale or if their lips turn blue, this is just very different for Black people. So this should be really accounted for. So that's from a data perspective. Similar for a problem that we're having is representation of women in healthcare data. Actually, women make up less than 30% of clinical trial data, and that has real consequences. In fact, it means that women are half as likely to receive proper treatment for heart failure than men, and they are twice as likely to die 6 months after discharge. And this is because the symptoms that these doctors were trained on, and that we also train our algorithms on because it's in the data, they are mainly of white men, older white men as well. So there's just not enough familiarity basically with the symptoms of women, which are slightly different actually than men for heart failure. Another problem that we're having is that it's amazing that the amount of data sets that have become publicly available, and I think that that's great. From a researcher perspective, we can use this data to create our very large models. But the point is that actually a lot of these data sets are not properly curated, and they are riddled with errors. This is a very interesting website, labelerrors.com, and it shows for many large data sets that are really often used to train models on, that they have significant bias. Okay, it's racist bias or sexist, or the data was not obtained with consent, or the labels are just plainly wrong. So I would really urge you, if you're also using these public data sets, also search for, sometimes there are also versions released that try to accommodate for that. But it really has an impact, because the models that do not perform as well on these biased data sets could actually be or have been shown to be top performers when these labels are corrected for. So it really influences what we determine are our most accurate or best models. A very interesting but challenging bias is the use of proxies for certain outcomes. So this is a tricky one, because often what we do is we're not allowed to use sensitive parameters in our algorithms, in the sense that, for example, race or gender or income directly is often not allowed. But then we also need to think of how do these correlate with the things that we are actually measuring or actually predicting. So this is an example where there was this algorithm that was actually deployed, or maybe it still is, but in the US, to flag high-risk patients for extra medical attention. And there they looked at the symptoms, and it was found that Black patients were less likely to be flagged for that extra medical attention than white patients, even when they were equally sick. And why that was happening is that the algorithm was looking at predicted healthcare cost instead of actual illness. And why that is problematic is that because Black patients have historically incurred lower cost because they did not, for example, have the same access to healthcare, or were not living in the right neighborhood to get healthcare, or they had lower income in general. But historically, they had lower healthcare costs. So focusing on that rather than actual illness has led to this actually racial bias. And if they would have used medical data instead of this healthcare cost, then this balance would have been much better. Then I think something that is really underestimated is that as developers, we are making lots of choices. We are choosing maybe what features to include or how to set certain parameters, and also the loss function, how it's set. That can really make a difference in when it comes to picking one algorithm over another. So for example, DeepMind has shown that they are able to very well predict kidney failure up to 48 hours in advance, which is great and spectacular. But then for every true positive, they also produce 2 false alarms. Now, of course, it's great to have the founded true positives, but it really has an impact on the patient if you have a false alarm, right? Because you have to come in, you have to do maybe additional exams. So it also has a high cost to it. So this just shows that if there would have been maybe a correction for that in the loss optimization, then something and another optimal result could have been obtained. Last example I wanted to give is for COVID, which is very interesting. There has been so many predictive models for COVID, and there was actually a study done for all the models that were being proposed from January to October last year, and that showed that none of these models were actually fit to be used in the clinical domain because of methodological flaws and underlying biases. So this also comes back to what Jon was saying, right? So create with the physician, with clinical judgment on how useful is this, and not just compare to ground truth you have in data, but also how does it fit your workflow? Does it improve clinical practice? So this is also very important. Okay, so now I'm moving a little bit to what can we do about it, right? So I think Google also, I found this very interesting insights from research lead at Google Health. They had a spectacular kind of failure when they went into medical domain and they tested their product, and it did great in the lab, and then it did pretty bad in real life. And he had some insights, like the first myth is more data is all you need for a better model, but the quality of labels actually is more important. And this is a huge trend right now, trying to increase the quality of labeled data. Also accuracy, and the focus just on accuracy is not all you need. We need a human-centered approach. It also looks at robustness, looks at fairness, it looks at these different elements that are just not pure accuracy. And just having a good product is not sufficient for clinical impact. So you really need adoption in the workflow. So we have our own principles at Philips. We have data principles and AI principles. They're based on, well, I mean, I think over the past 5 years, there has been an explosion in reports and frameworks of ethical frameworks of AI. And also the EU has their own set of guidelines. And we really looked at that and kind of mapped that to what are the things that are really important for us and for our patients and users. So those are the elements for us. And as you can see, so I'm focusing now a little bit on AI principles, but of course, we want to do well by our users. We want to improve health and well-being. Interestingly, we do not want to take the human out of the loop. We actually want to make sure that a human has a place in the loop where he or she can override or has the potential to also kind of give feedback. Robustness for edge cases, right? So don't design for the average person. And then fairness and bias mitigation is also something that we really try to emphasize on. And then transparency. So to a certain degree, it will be good if we can explain our AI, if we can make sure that what's going on under the hood is to a certain degree transparent. So focusing a little bit on bias, Gartner predicts that in 2022, which is really around the corner, 85% of all AI projects will deliver erroneous outcomes due to bias in data or algorithms or the teams that are responsible for managing them. So that's 85%. That's pretty large. And I'd say so we are suffering from that as well. So probably everyone here is suffering from that if you're working on with AI. And we also asked our, the healthcare professionals that we work with and the IT professionals, are you concerned that these biases that exist in the world, but that they also are translated to our algorithms? And 93% was at least somewhat concerned. So this is also a need actually from our customers that we need to address. So that means that if you look at the AI lifecycle, it has these different steps, and go from data collection to processing, development, deployment, and you basically go back if you keep on collecting data. And in these different stages, you can have bias creeping in. And I think it's important to realize that it's not just at the data collection stage, which there has been a lot of emphasis on that stage. And of course, garbage in is garbage out. So it is a very important stage, but we should not also forget that there are these other many choices in the other stages that we also have to be aware of, where bias can creep in. So this is just, I'm not going through all of this. This is a lot of, but I just want to give you an overview that there are so many types of biases. And as you can see, they're not all in data collection. And there are different mitigation measures for all of them. So also, if you do encounter a certain type of bias, there is things that you can do about it, or if you suspect it. So just giving an example for the different stages. So of course, you can have selection bias, which is one of the main culprits in data collection. So that can be, for example, because there are small data sets, or like at Philips, we have preferred collaborations with certain hospitals. So this is also something that Jon addressed, right? So not just go to one hospital in our case, but look at many hospitals and see how their workflow is. Make sure that you're not biased to one customer. And also from a data science perspective, you could do different types of analysis to try to counterbalance that bias. Confounding bias could be because you are getting data, you're doing a retrospective study and you have not known the study design, or maybe you didn't know exactly the context in which this data was in which you got it. Then you can do stratified analysis, but there are many more things you can do if you, there are very interesting tools like IBM Fairness 360 or Microsoft's FairLearn, or there are many tools if you just Google that can help you identify and mitigate those biases. Loss function bias we discussed already briefly. It's really important, and I think this is one of the major challenges that we're currently facing, to translate kind of what the business or the customer wants to a model goal, and do that properly. That really, you need a domain expert there. You need to really talk to each other, sit in a room and see, what does it really mean? What types of errors should we prevent? How is the application being used in the end? That's really important there. And then concept drift, where you basically, the statistical features of the problem that you were looking at have kind of shifted over time. Maybe you did not do a proper monitoring, or there was an unexpected event in the world like COVID. So really monitoring performance over time and having this plan in place is also very important. So we looked at what for us are the main risk areas for bias, and also looking, of course, like what are other companies doing, what's happening in the world, but also specifically what are for us the problems that we're facing. And these are kind of 6 risk areas that we have identified. And then we currently try to translate those high-level principles that I showed you earlier, like on what are one of our principles is fairness and bias-free. But how to translate that to something that people can really use, or if they're working on implementing an algorithm, if they're working on collecting data, how can they really adhere to that? So that's kind of what I'm working on, trying to give people tools and guidelines to really implement those high-level principles. And I think all the tools and guidelines kind of are focused on these 3 things, which is just diversity in people, diversity in data, and diversity in validation. So this is the core of everything, but I will go in a bit more detail. So if you look at, what is helpful and what we think will make the most impact are these kind of 5 things. So one is really awareness and training in the organization. So we have established a kind of a center of expertise that goes, is really across different businesses and different products that we're having. It's really about creating a general way of working, and really kind of consulting people, how can we get or adhere to a certain quality level when it comes to AI, and then educating them about these different problems that AI can encounter, right? So talk to them about the different types of biases that occur, at what point should you be on the lookout for them. I think there's a very interesting algorithmic bias playbook that was by University of Chicago, I think. It has a very nice overview also of the different problems and what can you do about it. So really starting that conversation in your company or in your institution is really important, and setting up your own set of good machine learning practices. Then having standardized documentation. So this is talking about responsible AI metrics, having KPIs, doing proper versioning of your data, your models, your experiments. This sounds very easy, but it's surprisingly that often this is not yet properly done. And data cards and model cards is something that a lot of the bigger companies started doing. It's a way to document kind of metadata of your data sets and your model. It's about describing kind of the limitations and the context for which that data and that model can be applied. That's also something that we really encourage. Then standardized quality criteria. So really evaluating your AI-based solutions by looking at those criteria, and you can do that by doing different types of assessments. So there can be a maturity assessment if you're a larger company. It's kind of interesting to look at. So this is kind of our vision. Where are we now? How do we get there? How to breach the gaps? Doing bias risk assessment. So where are you vulnerable? And this can be actually done for every point solution that you're making. Doing test-driven development for AI. This is, I think, is still very much a developing field, but I think will make also a big impact if we can make this more standardized. Diverse teams. So this is really also the diversity in people. So this is actually one of the simplest and ways to prevent bias, is just having multiple people look at your solution, look at your code, and then people with as diverse background as you have or can get. So not just talking background, but also education level, and of course gender, and as diverse as you can get, basically. And also monitor that. How are you doing diversity-wise in your company? Do you have any targets? How are you improving over time? And then when it comes to the interaction with the user, having those continuous monitoring plans in place. So making sure that you have a plan on how do you capture, if people find a problem with your solution, or if how are you checking that your algorithm does not become outdated, or that there is a data drift or a model shift going on. This is also something to consider. So just going in on the cards a little bit, or zooming in a little bit, if you look at some of the large companies, they have these templates. I think some of them are even open source, so you can also just use them. And it's very interesting because it really describes, or it makes more clear for what the data and the model should and could be used. So also if you're talking about reuse and reproducibility, this is a great way to kind of collect the data that in one overview, preferably not too long an overview, you kind of see, okay, what's in the data set? Is it relevant for me? What are the potential biases? And can I apply it to my own context? Let me check. Yes. So if you look at the different kind of stages that you're going to when developing, we think that for measuring, testing, monitoring, evaluating, and learning, there are steps that you can do to be responsible. And I'm not saying we have all the answers, right? We are still figuring this out. It's a tricky domain, and every day there are new tools coming out and new ideas around this. It's a very active research topic as well, so that makes it also very interesting. But so the first is that measure. It's really about assessing the data and the AI quality. So make sure that you know what you're working with. And on the right hand, I put some tools that we are using to do that. Testing, so plan for failure. Basically, use these edge cases to test against, optimize robustness. Maybe I think one thing that would be great to do more in the future is do randomized controlled trials with AI, where the AI is the variable being tested. Have this proper documentation and versioning that we talked about. And then these feedback loops, making sure that you already plan for logging the interactions, making sure that there is a possibility to override. So specifically in the healthcare domain, very important. Make sure that you can include in your next version of AI any concerns, or that there is some kind of feedback loop if people maybe don't agree with the model, or maybe they do find it biased. It would be very interesting to kind of be able to keep that in the loop. And then if you want to make it really robust, you have to standardize it and make it consistent. So that means maybe having some protocols or integrating it in your process, that you do these checks or that you talk to each other about it, and keep on improving on that process. So final slide is on responsibility that I talked about. So everyone tends to point at each other, right, when it comes to responsibility, and definitely when it comes to quality processes. But I just want to say AI is a very multidisciplinary field, and I hope I've shown that along this life cycle, there are so many different influences that affect the AI quality. And that is not just the AI scientists, not just data scientists, it's basically everyone who is working on that product. And everyone has the responsibility to ask the right questions. So does it really fulfill the need of all target groups? Should we distinguish different types of errors? do we actually do better than simpler or just human solutions? And are we clear on what the limitations are? So that's kind of my main takeaway. That's it.
Thanks so much, Arlette, for this super clear talk. And I think there was also a lot of concrete stuff that other companies could actually use to improve their own way of working, I think. So that was really awesome. But fortunately, you stopped 5 minutes before the end of this webinar, because there's also some questions in the chat. So the first one, nice that we have Jon also here. You can both decide who actually answers the questions. But the first one is by Cedric Rodriguez. He asks, how do you think explainable algorithms could help detect these undesired biases that you were talking about?
Yeah, it's a very nice question. So it's, of course, a very active research area. And I think there are two ways to look at it. So on the one hand, you already have kind of methods that try to infer how AI is making its predictions, right? And TCAV, for example, is such a method. And there you also see that even things that we have not explicitly put in, like concepts like gender, that you may not have put in, can actually contribute to a certain outcome. So in that sense, it would definitely help doing those types of things. And then if you design indeed from an explainable perspective, I think it will help you to much earlier bring to light certain biases that might have stepped in. Yeah.
All right, thanks for the clear answer. So the next question I wanted to put on the screen is by Martin Luijks. He asked, one of the problems with expert systems of the past, like MySyn, which was, I looked it up, some also in the kind of an AI system that was focused on bacterial infections, I think, was the question of responsibility. So some observers raised ethical and legal issues related to the use of computers in medicine, regarding the responsibility of the physicians in case the system gave a wrong diagnosis. So he asked, what has changed? Maybe we can start with the question, what has that actually already changed, or in what way? Or is still the physician responsible for his or her decision, even if it's based on an algorithm?
Yeah, so currently in the medical domain, and this is also what the legislation is currently focusing on, right? So this is why in the EU you have now the proposed AI Act, which is saying if you have high risk, if you're in high risk area, and definitely you are in high risk area in healthcare, then you have to adhere to many strict regulations, of which oversight is actually one. So I think in those cases, they try to kind of ensure that there is a human who is actually responsible for those decisions in the end. But I do foresee that in the future, with more symbiotic systems, this might still very much be a relevant issue. I'm not sure, Jon, maybe you also have, from a physician, did you hear something about this? Are they concerned about this?
Yeah, it's definitely a super important question. I think you explained it well. So responsibility, or let's say stakes, are very high or can be very high in healthcare. So this is definitely an area where this is heavily driving the development, also from FDA. If you look at US products, both validation and proof for the algorithm to be correct, and also the interaction with the clinicians through the interface.
All right, thanks for that. We have even more questions in the chat, but I'm also a bit, I always want to value the time of the listeners and keep an eye out on the clock. But maybe you can actually answer those questions after this webinar has finished, because I think that is possible via the tool that we have, so that maybe we can share the answer like right after this talk. Then I will now just finish this specific webinar and thank everybody for joining. You probably want to do that, right? Answer the questions after this.
Yeah.
Okay,
If there's a way to do that, yeah.
So first and foremost, of course, I want to thank you two for giving these very interesting talks. I think we learned a lot today. So that was thanks for sharing this with us. Also, thanks for being so transparent about what Philips is doing in this domain. Thanks everybody for tuning in today. If you want to explore this topic further with us, then you can reach out to us via the contact details on the slide. We don't have any other edition of this webinar planned for the remainder of this year. But next year, I think at the start of next year, we will be back soon with a new series on responsible AI. And for now, it looks like we will focus that on cases like this, where we actually invite companies to tell about how they implement responsible AI principles in their actual daily practice, so that we can all learn from how this works in the real life. So we will, of course, invite you for that. So you'll hear from us. But for now, thanks for listening, and hope to welcome you again in the near future. Have a great evening, all.